Hey, welcome back. And in this lecture, let's test our application on the Beaglebone Black hardware. Okay, so just connect your Beaglebone Black hardware to the PC through the USB cable. Okay, so you need not to use any power adapter, or you need not to connect any SD card, or nothing is required. Okay, just connect your Beaglebone Black hardware to the PC and boot through the eMMC memory. Okay. So now after that, I just connected the MPU5060 sensor according to this table. Okay, so just do the connection if you have MPU6050 sensor. All right, so now I will just compile this. Okay, so let's build the project. Okay, so the project is built successfully. Okay, so you can see here the binary is generated. Okay, so now we have to transfer this binary to the Beaglebone Black hardware. Okay, I don't know why the connection went down. Okay, it is trying to connect to my Beaglebone Black hardware. Okay, so it's connected. Okay, great. So this is my desktop. So now let's drag and drop this application here. Okay, so I got the application here on the Beaglebone Black hardware and the terminal is off. Let's reopen the terminal. Just right click here and click on open terminal and click on OK, and now it is trying to get the terminal. Just type the password of the hardware. Okay, great. So let me take the sudo access. Right, so let's go to the desktop and change the mode A+X MPU. Okay, just giving executable permission. So now let's execute this program, and here you can see that the sensor is currently at rest, and these are the output I am getting out of the sensor. Okay, so now let's close this and let's analyze this. Okay, let me copy this. Okay, I will copy a small portion of the output. All right, so here this is the raw value which is emitted by the sensor, and this is a converted G values. Okay, so here you can see that the converted G values are as expected. Okay, there is no output on the x-axis. It is approximately equal to 0, and there is also no output on the y-axis. I mean, it is showing some reading 240. So but when you convert that into a G value, okay, that is closely equal to 0. Okay, but look at z-axis. Okay, so it is emitting 16,252 raw value, which actually matches with our data sheet, isn't it? So when the sensor is in the full scale range 0, actually the application is running at the full scale range 0. Okay, even though I explained you in the previous lecture that I actually put the sensor into full scale range 3, but later I changed it to full scale range 0. Okay, so for some experimentation. Okay, need not to worry about that. You can keep it in any full scale range. Okay, so I will just show you that in a moment. Okay, so but currently the application is running in a full scale range 0, and the expected value per G is 16,384, and we are getting 16,252. Okay, so that is closely 1 G, right? So our accelerometer is behaving as expected when the sensor is at rest. Okay, so now come to the gyro. Strictly speaking, gyro should show 0, 0, 0. Okay, so but the gyro is very sensitive to the vibrations which may be happening at my table, so that may not allow you to have the perfect values here. Okay, so strictly speaking, the gyro must show 0, 0, 0, but these are almost equal to 0, even though the y is showing a deflection of 1 degree per second. Okay, so that's fine. Now let's change this full scale range to, let's say, 3. Okay, we have to alter the code here. Okay, so in the MPU init, okay, so you can see here I am passing 0, 0, right? So that I have to make it as 0 cross 18. So this was the value I explained in the previous lecture for you. Okay, So now let me go back to the older value 0 cross 18, and now let me compile this. Okay, so compilation is successful, and now let me copy my application, and okay, so let's clear this out and again execute, stop it, and now copy, and here you can see that okay, so there is a problem. I did a mistake. Okay, so after that here you have to divide it by 3, isn't it? Okay, so make it 3 everywhere. Okay, all right, so now let's compile this, copy this to the Beaglebone, and now let's execute, and let's stop it, and let's copy these values. Okay, and here you can see that now the Z is showing 2025. Okay, so what your datasheet says, it must show 2048. Okay, so we are very close here. Okay, all right, so some of you may be wondering how to keep the sensor. Okay, so for example, here in this picture, okay, so I have placed the sensor like this. Okay, here the X direction is actually towards me. Okay, and okay, so here you can see that I have placed my screwdriver perpendicular to this sensor or to this breadboard. Okay, so the sensor itself indicates the direction. Okay, so if you have placed this sensor in this way, then this direction is positive Y. Okay, this is positive Y. Okay, so this direction is negative Y. Okay, and here you can see that X, okay, the X direction is marked, so that means this is positive X. Okay, and of course this one is negative X. And here I have placed my screwdriver perpendicular to this breadboard. Okay, so this is considered as the positive Z. Okay, and the other way is negative Z. All right, so when I place my sensor in this way, then I am getting approximately 0 value on the y-axis and 0 value on the x-axis. Why? Because Y as well as X both are parallel to the surface, isn't it? But the Z is actually perpendicular to the surface, so that's why this sensor experiences plus 1g of acceleration, okay, on the z-axis. Okay, and the moment you put this board upside down, okay, then you will see minus 1g of acceleration on the z-axis. Okay, all right, great. So now, because knowing these directions are very important for our next experimentations. Okay, so whenever I say tilt your sensor on the positive y direction, what you do, this is the positive y direction, and if I make something like this, then okay, this is tilting of the board on the positive y direction. Okay, so this is tilting of the board on the negative y direction, and this is tilting of the board on the positive x direction, and this is tilting of the board on the negative x direction. Okay, so please note these points, and we will do some experimentation on that. Okay.